Hello. Today I'll be going over Fall 20 final question 1. So question 1 is what would Python do? And part A is create a linked list called foo such that the following statement returns true. So you're asked to fill in this blank that makes this statement return true. So basically they're asking you to create something that satisfies all these following statements. So the first one is that you want to have the length of the first element of the linked list equal to the second element of the linked list. And the first letter of the first word of the linked list should be T, and foo.rest.rest.rest equals linked empty. So they're saying, I'll draw this out. So you have your linked list structure. You know that the first one, that these two should be equal length, and that the first letter of this one is the letter T, and foo dot rest dot rest dot rest dot rest is link dot empty. So what you basically want to do is just construct a list instance that fulfills all of these requirements. So in this case, you could do anything. I'll choose to say foo equals link. My first word will be turtle because it starts with T. And then following the link syntax, we want another word that has the same number of letters as turtle. So turtle has 1, 2, 3, 4, 5, 6. So we want another word that has the same word or same number of letters, and in the answer they came up with lizard. And then the third element, there's nothing about it in the statement, so we can make it anything. The answer says it can be frog. And then, so we know that since the last link is link.empty, we know that this is the end of the linked list. And let's just close up our brackets here. So this is the answer to part A. For part B, it says, given the lines of code and results, fill in the blanks so that the results appear properly. There are 2 blanks in this problem. So they give you a class called Candy, and they have their init method, which contains the color and the price. So this basically tells you that if you want to create an object of a Candy class, you have to pass in color and price. And outside of it is a method called shop, and you pass in candies and colors. So we go down into this method and we see total equals 0, and we see 4 candy and candies. So this should give us the hint that candies is a list of objects of the candy class. So candies equals a list of the a list of candies. So if we go into the for loop, it says if candy color is in colors, print I like candy color, and then add to the total. Else print I don't like candy color, and then at the end we're going to return total. So in the code that they're giving you, they're saying total equals, and they're applying the shop method to a list of candies here, and then a list of colors here. So you're seeing that it's printing out, I don't like blue, I like red, I like green, and I like red. So as we see in this else statement, we're saying if the candy colors in the list of colors, we're printing I like, and if it's not in colors, we're printing I don't like. So we have an idea of what would be in colors. So colors, included in colors is red and green, and not included is blue because it's the only statement that says I don't like blue. So the other piece of the problem is that at the end, if we print total, that's associated to this return statement. So we know that the total, which arises from adding together all of the candy's prices, should be 42. So candy prices should add to 42. Okay, so in the solution, so basically what they're asking you to do in the first blank is construct a list of candies, and now we know that colors contains the colors red and green, but not blue. So we can fill in the second blank with the strings red and green. You could make this any iterable, but a list is preferred because it's easiest to check in colors. The in operation works with the list, and it's the simplest in this case. So for candy color, or for candies, we know that we have to construct a list of candies that is 1, 2, 3, 4 long, so 4 candies, and the total has to add up to 42, and it has to contain a blue candy, a red candy, a green candy, and a red candy. So keeping all of these in mind, let's create our list here. So in order to create an object of the class candy, we need to say candy, and then we're passing in a color and a price. So the first one's color is blue, and we'll just say that the value is 10 because we know that that the prices have to add up to 42. So the first candy can be blue with 10. The second candy has to be red. I'll make it 20. And then the third candy we know should be green. And I'll make this 2. And then the last candy will have red again. And now all we have left is 20 to make it add to 42. So this is just one example of an answer. These parts should be fixed, but these numbers can be anything as long as all 4 of them add up to 42. Okay, lastly, moving on to part C, they're asking you explain in 1 sentence and less than about 25 words what the following mystery function does if given an instance T of the tree class. The tree class is also included for reference. So we've seen this tree class before. We should be pretty familiar to it. I've included 2 trees as examples, and so let's move on to mystery. So you can see that mystery has a function inside of it, so it's a higher order function, and it returns hoopla, but hoopla had something passed into it. So let's just try to walk through what hoopla does using this tree as an example. So if it's returning 0 plus t, let's say t is equal to this. So we're saying I equals 0, and then z equals this tree passing. So if we go to the first line, we're saying m equals 0, and then we're saying if I modulo 2 equals 0, m plus equals z dot entry. So we see here that right now we are at we're at an 0, so 0 passes through this if statement, and then we're going into m plus equals z dot entry. Z dot entry in this case is this number 1. So our m is currently 1. And then moving on, we're saying return 1 plus sum of hoopla of I plus 1 of b for b in z dot branches. So our z dot branches in this case are, our first branch is here, and then our second branch is here. So it's saying right here hoopla is 0, and then t, and then in this level hoopla is 1, and then branch, or what we pass into as a second argument doesn't really matter. So in this case, I'll say dot 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 because it just represents one of the branches that we're going into. So since we're moving into this instance, we're saying m equals 0 again, and then we're saying if I modulo 2 equals 0, in this case, our I is 1, so it's not passing it. So we're not saying add something to m, so m is unchanged. And our m in our first call to hoopla is still 0, so we're keeping it at that. And then so as we move down in the branches, we're also doing hoopla 1 for this branch, and then now we're moving on to 4b and z dot branches for both of these. So in this case, our branches will be here for this one, and then here for this one. And then we're basically saying on this level, we're doing hoopla 2, and then we're seeing a pattern of basically, we're starting with the 0th level, we're going down each level, and we're saying if the level number is able to be divided by 2, so if it's even, we're adding each value to the entry. So in this case, if we say hoopla 2, in each branch, it's going in and adding 1, 1, 1, 1. So our m will be 5, etc. We'll move on to the next level, say hoopla 3, and since this is an odd number, we're not adding anything to our m, and then we're finally going on to this level, where since we're saying hoopla 4, we're adding in these 2. So we're saying 1, 2, 3, 4, 5, 6, 7. So now we're saying n equals 7. So as you can see, in this tree, the example will look the same. So these numbers will be added up. So I hope that that gives you a better sense of what the function is doing. So the answer would just be something like mystery adds up the values of all the entries in even depths in the tree. So the reason why I'm saying even depths in the tree is because depth just means how far away from this base node you are. So in this case, depth is 0 because this is the root. So we're 0 away from the root here, we're 1 away from the root here, we're 2 away from the root here, 3, 4, dot, dot, dot. So this is just a concise way of saying and yeah.